Okay, all right, so first of all, let's start right in off the bat. We got to start with number 5. This looks a lot like the number 1 we did yesterday on the first review question of our practice guide. It looks really close. This was the first section when we started doing derivatives for the first time. It was like section 2.4 or 2.3 or something like that when we did the instantaneous rate of change problems. We did the differential quotient on this section, and we talked about how do you do it. You guys wanted to know the shortcut, and we did that in the next section, 2.4 or 2.5. I think it was 2.4, and we learned the shortcuts, like the power rule and other things. So what you have to do is you have to take this problem and plug it into this function up here. So that is taking this function and plugging x plus h into all the spots that have x's. So if it doesn't have an x, it won't get an x plus h on it. Then you're going to have to subtract the original function. That's this part right here.
Why don't we just do this?
And so the original function is this. What was that?
You can't do the thing where you just use
No, you have to show me that you can do this by the old school method. So you know the answer. You knew it was going to be 2x plus 5. So this should prove it in the end. So, because you knew the power rule. You knew how to take the derivative of that thing before we started. So that's the beauty of this. You know what the answer is going to be in the long run. All right, so now we plug this in. We have to FOIL, distribute, however you want to say it. This parenthesis right here is x plus h times x plus h. You have to actually distribute and FOIL. Don't distribute the power of 2. FOIL it together. So that's x squared plus 2xh plus h squared. If I FOILed it out, first, and last. Sorry, I'm going really fast. I'm going to keep going. Distributing the 5 through here, I get 5x and 5h. I have that, plus 7. And then I'm going to distribute the negative sign in the back here. So I get negative x squared minus 5x and then minus 7. Here's how you know you're doing it right. If everything that does not have an h cancels out. That happens. Look at this. Everything that doesn't have an h literally cancels out. You can see it up there. So what I'm left with is I'm left with all these things. 2xh plus h squared plus 5h. And this is all still divided by h. Okay, questions up to this point? Now, if you haven't noticed, I haven't put the limit out front yet. I'm just trying to simplify this thing all the way down still. This is a lot like what we did on problem number 1, by the way. I just didn't tell you. That's what we had to do on the homework.
Boom. 2x plus 5.
Okay, so we divide everything by an h. So we get 2x plus h plus 5, right, when you divide everything by h. And then the last step is now we have to put the limit out front. The limit as h approaches 0. So if you plug 0 for h, this is what we're left with. And that's exactly what we said it was going to be in the beginning because you knew the power rule. So that's why it's nice to know the power rule. You already know the answer going into it. You just have to double check it. Okay, now, the only difference between this problem and number 1 is number 1, maybe when you simplified it, you still couldn't plug in 0. Because maybe the h's didn't all cancel out on number 1. So on that one, you'd have to plug numbers very, very close to 0, like 0.001 or 0.00001, and see where the decimal's going on number 1. On yours, you didn't have to do that.
I'm gonna have to go through my trash at my house to find this thing.
All right, let's move on. Okay, all right, number 6. Power rule, we're doing second derivative. That's the one thing I'm kind of worried about. Read the directions when you're going through each problem. We're doing the second derivative here, right? Find the second derivative using the power rule. So we're going to do the first derivative, and then we'll do the second derivative.
Wait, what's the other rule where it's not the power rule?
Quotient rule, chain rule.
No, I mean like, what's the last problem we did?
Differential quotient.
Okay, so it says using differential quotient.
Yeah, it said that when here.
Okay.
Here's what it looked like.
Okay.
Yeah. Okay. What were we saying? Okay, never mind. Never mind. All right. Let's do the power rule here. What do we get on the first derivative?
Or did you notice I put that on my homework? Like on our assignment, I put Quotient Rule on top.
Quotient Rule, I know. I can't ever let that down.
We're gonna ruin your career.
I know. It's already in the bag. All right. Okay.
What did you say, oh God, what
Okay.
was it?
The rest is just like join.
Okay. First of all,
No, but I said something yesterday.
hey, what is the power rule here?
Show me
Fifteen
the
x to
answer.
the fourth plus
Okay.
12x squared minus 44x.
Good. Yep. 15x to the fourth plus 12x squared minus 44x to the first, and then the 10 dropped out to be 0.
Then you can do it again.
Then we have to do it again, absolutely. So, because we're finding the second derivative by the power rule. Drop the power up front, we multiply it. Well, 4 times 15 was that 60? Times 15. So 60x to the third, 24x, and minus 44. Because we dropped the 1 out front and you'd subtract the x off. Right? That's the second derivative. That's what I want. I'm going to let you know right now. It will be it'll be probably a second derivative, and it'll be something with power rule very, very quickly. You should know what you're doing. It's not going to be a chain rule. What?
What do you mean very rigid?
It's like one of these where I consider that a quick problem. Like this should be one of the fastest problems on our test. That one. Okay?
Oh, wait, no, they have.
All right. 7. And again, if you're at home and going too fast, just let me know. I'll back up. I know it's hard at home and it could be blurry. Sorry. Okay. All right. Okay. Quotient rule. Okay, so this is the one we did on a worksheet. I think this worksheet was, what was this? 2.6 worksheet we did like last Tuesday or last Wednesday or something like that. Quotient rule. So, and I think it was due last Friday. So, all right, for the quotient rule, you have to take the derivative of the top. So, derivative of the top, which is?
4x
Yep,
minus 18x squared
yep,
plus 16.
x. Okay. Okay, so we have that, right? That's the derivative of the top. We have to take that times the bottom. Then we subtract the derivative of the bottom, which is
Oh,
two-
derivative of the top times the bottom, then
Yep.
the derivative of the bottom
bottom times the top.
Okay, so 2x plus 2.
Yep. X fourth plus 6x to the third plus 8x squared. And then we have to put it all over
Bottom squared.
the bottom squared, which is this. And no, you do not have to simplify. In fact, I'll probably type that in there. Do not simplify number
I
7.
will spend 45 minutes.
Oh, I know. I don't want that. You need to get just going through this test. So I want problems to be short and simple and like quick hitters. Do not simplify. In fact, I'll probably type that on the test tomorrow. Do not simplify this.
Hey, Wolf,
Yes.
you're not gonna make us find the second derivative of this.
No. The reason being is that would be like the next section that we do, the next unit, where we have to like simplify derivatives down or take a second derivative of something like super complicated like this. No.
That's still the wrong answer.
So good question. No. Okay.
Well, you get it wrong if you simplify.
No. If you simplify it wrong, yes.
Oh.
So I would probably just suggest you stop. So, all right.
I'll simplify it wrong.
Okay. Let's go to number 7. All right, chain rule.
Wait, you subtract
I need you to
the
slow
derivative of the
down.
bottom times
Yes.
top, right?
Say it
I
again.
need you to run it back and slow it down. Thank you, sir.
Or
That's all.
number 8. Oh, never mind.
Sorry, we had to go back.
Let's go.
We're fine.
No, you said let's go on to number 7. I said no, it's
Yeah.
number 8.
How am I supposed to know what I'm doing when you don't know what you're doing for?
Okay, sorry.
I don't know why. It's like when you did that, your legs got like 3 times as bad.
Oh no.
Just from this angle, it's just not good.
I've been bullied the last period. No one bullied me this period.
Bully free zone.
Brayden?
Oh, don't attack him.
That's right, Ward. It's free to bully. Doesn't cost you anything to be mean to someone.
Except your reputation.
Yeah.
Nice if someone's really good.
You're dumb if you think my reputation is garbage already.
All right.
I leave my
Hey,
dignity at the door.
moving on. All right. Okay, so now here's what I'm worried about. On number 8, the chain rule. This problem could be a trig function. It could be a kind of a chain rule, power rule like this one. It could be an exponential. It could be, something with e, which is also exponential, but it's, natural
That's
numbers.
the stuff I can't do.
So we need to be able to find the derivatives. You'll see that on the next problem when we do the product rule. You do need to know exactly what you're doing. So on this rule, this is the chain rule overall. We have to drop the power out front, subtract 1 off the power. Now when you do that, the inside didn't change, right? You just drop the power up front, you subtract 1 off the power like normal. Now the inside is what you have to do second. Yep, that's the second part, which is the 8x plus 2. Because that's the derivative of the inside. That comes after. Now, how this could be different. Now, I'm just going to make this up. I'll put it over here in the corner. If this was a trig function, this is one of the questions I had the other day. It was something like this. Okay? Let's say it was something like this. Okay? Shh. Oh my gosh. All right. So here's the idea. This problem can be... this problem could be written like this. This would just be a different way of looking at this problem. I forgot an extra parenthesis. Where you have to drop the power up front and subtract 1 off the power, right? And the tangent still staying in here. X squared plus 7x. All right. And the idea is that after that, then you take the derivative of the inside. The derivative of tangent is that 1 over cosine squared. So this is where you really have to know all of your rules, and so you have to go back to my notes that we covered to talk about all the rules for derivatives.
Can you just have that written on the board?
No, that's the stuff you have to have memorized.
Are you kidding?
No, you got to know your derivatives. And then we have to take it times the derivative of the inside of that item, and that was the 2x plus 7. Because the derivative of tangent's 1 over cosine squared, and then if there's something still inside, then you have to take the derivative of that.
Please don't do that.
So, first, you just do the thing on the outside.
Yep.
Boom. Then you multiply it
By the derivative of the
inside.
inside. Yeah.
Okay.
Question.
What if I just put secant squared?
You could do that. You could just write secant squared with that
Is
parenthesis.
there one that means all of them? Is there one that's like the derivative of all of them?
No.
God damn it.
Okay.
I was hoping there was like a master.
Again, this is if I was doing this problem, this is written the same way. It's just it's the same problem, it's just written differently. That was the question I had yesterday. Is like, what does that little 2 mean? That's the thing you drop out front. So I just wrote it differently so it means the same problem. This, what you're looking at right here, this is the first derivative. This is actually me taking the derivative. This was just the function.
I need to be more strict on who we let into this class. I do not belong here. Okay, just because 7th grade me could do beginning pre-algebra does not mean senior me needs to be here. Okay?
Moving on. Oh.
What do you do if there's an X?
Just because I haven't failed any of that class
There's an X in the power?
Then, if there's an x in power, then you have to do that exponential rule. We'll see that in the next problem. We're going to put an x up in the power. Yep.
Rich don't have to fail
Wait,
for
so
them to
if
be
it's
like,
half,
hey, you're not on
if
it.
like half is the exponent, when is it when it goes to 3 over 2?
That's when you subtract 1 off of it. Yeah. Yeah, if it was like -1/2 and you're subtracting 1 off, that's -3/2, right?
Okay.
Yeah. Because you just subtract fractions. Like half minus 1.
Do I ever have to take a calculus class again?
Probably not. Shouldn't.
Or in college?
Depends on what major it is.
Psychology.
Probably not.
Yeah.
You'll probably test out. Okay. All right.
What if I engineer things? Yeah, see, I think that career is just falling off the cliff.
Okay. Anyway, let's discuss this one now. This is the product rule that we talked about yesterday. This is where so this is the problem we talked about on Monday and Tuesday. You have to take the derivative of the front, and then you take it times the second, and then you add the derivative of the second times the front. So this is the first item. This is the second item. And how I know that they're separated by a multiplication. This is called the product rule. This is the stuff we did Monday and Tuesday this week. Okay, so how you do this? The derivative of the first. So when we take the derivative first, this is the thing you guys were asking about. What happens when there's an x up in the power? So I have an x up in the power. It's 2 to the 6x, right? That's where you do the natural log of 2 times the original item times the derivative of what's in the power, which is the 6.
You're gonna have to say that one more time.
When you take the derivative of an exponential, it will be the natural log of the number that was the base
Okay.
times the original item you started with times the derivative of what's in the power.
Holy crap.
That's a chain rule. Now that is just to explain that is just doing the first item. That is the derivative of the first item. I still have to take it times the second. So that's the tangent of 3x. Okay? So that's the derivative of the first times the second. Now I have to add the derivative of the second item. So what is the second item up there?
Why are we adding, not subtracting?
This is the product rule. You only subtract in quotient rule.
Not multiplying. I'm confused.
Because this is a derivative of the first times the second.
Yeah, so on product rule, it's derivative of the first times the second plus, because it's a product rule, so plus derivative of the second times the first.
So instead of top and bottom, it's first and second.
Yeah.
Derivative of first
Okay.
plus or times
It's the second
second.
plus the derivative of the second times the first. So now, what is the derivative of the second item? Well, that was 1 over cosine squared of whatever that item was, times, what's the derivative of the inside of tangent? What is the derivative of that 3x? That's just a 3. That's the derivative of the tangent part. It's a chain rule. Derivative of tangent's 1 over cosine squared. And then you have it times the inside of it. So now, we have to take
Can
it
we have a partner for this test?
No. Now we have to take it times the first. The first was 2 to the 6x. There you go. So again, I'm just gonna now what I'm about to write is just highlighting what we did. It is the derivative. It is the derivative of the first item, right? That's the derivative of the first item times the second item, right? That's what we did here. So derivative of the first times the second plus the derivative of the second item times the first.
Okay, so why do you have the, at the very end, you have the 6x?
Yeah, because that was the first item. Derivative of the second item is this part times the first item. First, second.
Wait, where did 6 come from?
You don't work.
The 6 was it was a chain rule. When I did the derivative of the first item, that was this thing right here, right?
Oh,
When I did the derivative of this first item right here, it was the natural log of the base times the original item, but that power had a weird thing in it, so it was a chain rule, so I had to take it times the derivative of what was on the inside. That's where that came
Sine
out.
is cosine and cosine is negative sine.
Yes.
E is E and
Yes.
A is ln A.
Yeah, which is this.
Natural log times the base times the original times
So you can have.
The derivative of the power.
derivative.
Yeah.
Oh, yes, there's another one.
If it's an exponential.
So what is this?
If it's not, you just do normal power rule or whatever.
Okay.
I just picked 2 things so we could review them. Okay, last question of the day. I think this is our last one. These are the ones we finished with on Tuesday at the end of class.
you won't tell us to
I
do the
don't know
second
how to
derivative?
do
No, it'll be first derivative only. First derivative only.
You promise?
Yes.
Okay.
Promise.
Thank you, promise.
The reason why is I don't have enough room to put a second graph. So it's going to have to be first derivative only.
Right, you know, let's go.
So,
That's what I thought.
okay, so, okay, so, all right, first,
Hey, don't let him bully you, Warren.
bully free zone.
Keep your pride.
Okay.
Keep your
Oh
pride.
my goodness. All right, what is the slope right here?
Don't let her shine through.
Hey, what is the slope right here?
Negative.
Negative numbers, right? So, okay, so the derivative on this side, the slope, is all negative numbers. So I'm going to have negative numbers up until about half. At half, it hits 0. So I had all negative numbers until about half. These are all negative numbers.
How do we do? We just gotta kind of make. Okay.
And then after that, the slope turns positive for a while. Up until about, what is that, about 2? So up until about 2, then it comes back to 0 for slope. So up until about 2, it will come back to 0. So it might do something like this. So it went positive for a little bit and then dipped back down to 0. Because this is 0 slope. That's when it hits a peak. And now, the next part, I'm going to have negative slope up until about 3.5-ish. So up till about 3.5, I'm going to have negative slope.
So I just got to remember that my mins and maxes are going to be X's.
Yes. Yep. That's your peaks and valleys. Yep. And then we're going to go to the next part, which this is positive slope up until about, what is that, 5? It's about 5 when it will hit 0. So up until about, so it was 3, 4, 5. So up until 5, it will come back to positive numbers and come back to 0. And then it will go just straight negative numbers after that. So straight negative numbers at this point, and so it'll just dip it down below like that. And that's your last one. It'll be a first derivative graph guaranteed, because I don't have enough room to put a second graph in there for the people at home. If you're at home, you're just going to draw a rough sketch. So you'll just do something like this. I only need to see the hash marks you need to be hitting. So at home, actually the graph at home will actually be easier, because all you have to do is put the numbers I'm hitting. I'm hitting 2 or -2. I'm hitting 3.5 and 4. So like you can just tell me like the nice numbers you're hitting. So at home, like this problem could actually be easier than doing it on an actual grid. Questions? Okay.
Have you ever had a male cry during a test?
I've had students cry. Yes.
Back to the graph when you're done.
Yes.
Have you ever had a male cry during a test?
I've had students cry. Yes.
Hey Ward,
What's up?
Have you ever had a male cry?
so we just take pictures of this at home?
Yeah, you'll take pictures of this practice guide at home, and you're gonna resubmit them to me as your practice guide on Google Classroom. Yep. So if you guys have not been on Google Classroom, make sure that you're going in there, you're resubmitting stuff to me. I just haven't looked in the last couple days, so it's up to date. I just haven't looked back to see if somebody resubmitted something, or maybe you saw that you had an LI, so you resubmitted it. So go in Google Classroom. Test is tomorrow. For those at home, you'll just write it on a piece of paper. Just make sure your camera's in a spot where I can see your hands working. I don't need to see your work necessarily until you're going to take a picture and send it to me. But no cell phones, nothing. Don't use your cell phone as a calculator. Make sure you have an actual calculator at home. For graphing like this, just draw a generic graph. Do the best you can. I'll give you a little leeway. So, but all late work is due by 11:59 tomorrow. So if you checked JMC, you checked Google Classroom, it's due by 11:59. After midnight, I delete all the stuff in Google Classroom so you can't resubmit. So they go away at 11:59 tomorrow.
Look at my camera roll. It's just...
Who played before? Who played all these?
No idea. Okay, but that's it for today. I'm going to stop recording here.
Okay, you want to go?
Me and Brandon, that was our game.